right? So here I can let go of this right now. Can let go of that. Yeah. So we can let go of that. So now we have what we want on a variance. Now we understand what deviation is right now. Okay, so we can let go of this too. Now let's go down back to what variance is right now, or what does variance measure now. So variance is also used to measure spread. So it's like a concept in which you do not want your deviation to be zero, and since in the standard level we do not want our deviation to be zero, so we say the variance of x equals right now with what I show you, the summation of f, right? And then we are multiplying that by x minus bar x, which is your deviation, but we do not want it to be zero, so we square it. Because if I did not square it, if I didn't square it, in that way my frequency multiplied by 0 is going to be 0. So in that way is the reason why I'm squaring the deviation, so that I don't want it to be 0. If you watched the previous video. And then here we have it now, and we are dividing by summation f. Okay, this is good. Now in here I'm going to turn this around right now to say the variance of x equals, I'm actually summing all of this up. So I'm going to say in this way, since each of this is going to be done for each of the data, so I remember that the summation of x minus bar x all square multiplied by the frequency divided by summation f. Okay, things are getting intuitive here. Things are getting really intuitive here. And if I do this, frequency divided by summation f, I'll take you some step back to the beginning of the video where we talked about what probability of x is. Some of us might know that at this point. You will know from here. If you want to get this, basically I can walk you through the previous video, okay? And then you see that the frequency is 3 divided by, could you see the frequency is 3 divided by summation f, which is 20, and I call that the probability distribution. Did you see? The frequency was 3. See, go ahead here. The frequency was 3 divided by 20, we call that probability of x. Did you see? So in that way, I could go back to the current right now to think of this exact thing I have here, this here. And I'm going to call that the P of x. Which is the probability distribution. Now this is coming out handy. The variance of x will now be the summation of x minus what now? X bar all square multiplied by the probability of x. Hope this is getting handy quickly. We talked about the central value here, which is the mean. That is the mean. That could be represented by this or by expected value. You agree? So we can change things around and say the variance of x equals the summation of x minus the mean or square probability distribution of x. This is getting quickly. Now, which means that this guy here can also be represented by the expected value. I could do that again. So in that way, there are two formulas I have for my variance here. So variance x equals right now summation of x minus mu all square by probability of x, or the variance of x equals the summation of x minus the expected value all square by the probability distribution of x. This is variance, and this is how variance comes to play in your unit. That makes some sense? Now I can move this right now and talk about standard deviation. So take note that the standard deviation represented by the symbol here, that is the standard deviation. And the standard deviation, right, is definitely the square root of the variance. So the standard deviation equals the square root of the variance of x. So if I need a new symbol for variance, I can square both sides. So if I square both sides, that will be variance square, that will be standard deviation square, equals the variance of x in roots but all square. And this will give me the standard deviation square equal to the variance of x. So which means I could represent the variance of x by the symbol, right? Whereby this is the standard deviation and this will be the variance. So when you see the symbol square, that is the variance. When you see the symbol like this, that is the standard deviation. You just want to know that in that way. Standard deviation, standard distance apart, right? So in the variance, all are the measure of spread. Does that make sense there? So this is the measure of spread in intuitive way. So we've gotten variance, we've gotten standard deviation, all in a chalk, we have everything to the blue. So in this concept, we can balance out our unit formula right now, that the standard deviation all square, which is the variance now, equals summation of x minus mu all square to the probability distribution of x. And I can say the standard deviation, right, equals, right, the square root, that will equal the square root of summation of x minus the mu all square, the probability distribution of x. There you go with this variable like that. So this is just the idea you want to blossom here. This one here is the variance, and this one here is the standard deviation. You don't want to mix all of that up. It's highly intuitive. You should not mix it up. So we have the variance, and then we have the standard deviation, which is actually used to kind of select what we want around the corner. So this is how we move with this. Now, if you've been following this video, you will notice that we've been able to try to break up into two pieces the expected value, and then we'll be able to get the variance and also the standard deviation. We're going to use this a lot in most of our data as we go on to other variable ones and so many questions that will follow under here. So in the next, I'll be talking about relationship between variance and the expected value. So the relationship between the variance and expected value, you might have seen it from the figure we have up there, right? It's so direct that we have it up there. So in a way to think about it right now is to think about it like this. Let's do it this way. What we know now is that the variance of x equals the summation, right, of what now? X minus, I'm going to just use the mu,